Good day everyone, we are Group 1 and we are going to present about balancing nuclear binding energy. But before with that, what is nuclear binding energy? Nuclear binding energy is an energy required to separate the nucleus into its individual nucleons. Energy that is released in assembling a nucleus from its individual nucleons. Why do we need to balance the nuclear binding energy? Balancing nuclear binding energy refers to the process of ensuring that the number of protons and neutrons in a nucleus is in equilibrium. This balance is important for the stability of the nucleus. Nuclear fission. In the context of balancing nuclear binding energy, nuclear fission can help achieve a more stable configuration by splitting a heavy nucleus into two smaller nuclei, which may have a more balanced ratio of protons to neutrons. This process can release a significant amount of energy. These are the units that we need to balance the nuclear binding energy. The binding energy of a nucleus is the energy required to combine individual protons and neutrons into the nucleus. Some of the mass of protons and neutrons is lost to create the binding energy. So these are the formula that we need to balance the nuclear binding energy. E is equals to mc squared. This is where the mass defect goes, so binding energy is equal to mass defect. So these are the conversion that we need in solving the nuclear binding energy. 1 AMU is equals to 1.767377 times 10 minus 24 grams, or 1.67377 times 10 minus 27 kilograms. In MeV naman is equal to 1 MeV is equal to 1.602176663 times 10 minus 13 joules. In speed of light naman is equals to 3 times 10 raised to 8. So these are the example for your better understanding. Example number 1. Consider a nuclear reaction where a uranium-235 atom undergoes fission and splits into two smaller atoms, a krypton-92 atom and a barium-141 atom. Calculate the change in nuclear binding energy for this reaction. So, step in solving. 1. To calculate the change in nuclear binding energy for uranium, the reaction, we subtract the nuclear binding energy of uranium-235 from the total nuclear binding energy of the products. Step 2. Total nuclear binding energy of the products is equal to nuclear binding energy of krypton 92 plus nuclear binding energy of barium 141. Change in nuclear binding energy is equal to total nuclear binding energy of the products minus nuclear binding energy of uranium 235. So 92 plus 141 is equal to 233 minus 235 is equals to 2. Step 3. Convert all the atom into MeV. Uranium-235 is equals to 1,782 MeV. Krypton-92 is equals to 918 MeV. Barium-141 is equals to 1,099 MeV. Step 4. Total nuclear binding energy of the product is equals to 918 MeV is equals to 1,099 MeV. Change in nuclear binding energy is equals to 918 MeV plus 1,099 MeV minus 1,782 MeV. Therefore, the total change in nuclear binding energy for this reaction is 235 MeV. Example number 2. How many MeV of energy can be obtained from 5 grams of hydrogen using Avogadro?
So, hello guys, good day. So, I will teach you how to solve this given problem in nuclear binding energy. So, using Avogadro. So, first thing we need to do is convert the 5 grams into kilograms. So, 5 grams is equal to 0.05 kg. So, now we can proceed to the equation the, to solve the nuclear binding energy. So, E equals mc squared. Lagyan natin step. Hindi mali to. So, the given mass defect is 5 grams of hydrogen. So, yun ang gagamitin natin. While the value of speed of light is equals to 3 times 10 to the power of 8 squared. So, now we can proceed to the equation. Let's solve 0.05 grams times 3 to the power 8 squared. So, pag kinalculate natin yan, ang lalabas is 4.5 times 10, 14. So, tingnan natin yung problem. So, we need to use Avogadro. So, ang equation nan is step 2. Parang conversion lang din siya. So, our answer, 4.5 times 10, 14 times 1 mole. So, 6.82 times. Step 3 na pala is 6.22 times 10, 23. So, pag kinalculate yan, ang lalabas na sagot is 7.47 times 10 negative 10. So, we need to convert our answer because our answer is into joules. So, we need to convert the joules into EB. So, step 4 tayo. Our answer, 7.47 times 10 times 1 EB is equals to 1.602 times 10 to negative 19. So, pag kinalculate natin yan, ang lalabas na sagot is 4662921 So, nasa EB pa lang yan guys. So, proceed tayo sa equation. How many MeV of energy? So, MeV yung inaanap. So, i-convert ulit natin yung sagot natin na EB to MeV. So, yun yung step 5. Sinulat ko na. So, EB to MeV. So, ang value to convert, we need to divide our answer to 1 times 10 to negative 6. So, pag scientific calculator natin yan, ang lalabas sa sagot is 4,662.921,348. So, yun lang guys. So, tandaan lang natin na kapag given yung mass defect is kailangan i-convert muna natin siya into kilograms pag nasa grams siya. So, pwede na tayong dumaretso o proceed sa equation ng nuclear binding energy which is E equals mc squared. So, kapag kailangan gumamit ng Avogadro, ito yung Avogadro's number which is parang conversion lang din. So, nasa joules pa yan. So, convert natin yung joules into EV. So, pagka-convert sa EV, convert natin yung EV to MeV. Dahil yun yung hinahanap sa equation. So, yun lang. Thanks for listening and watching.
Example number 3. Helium-4 nucleus 4/3 helium in terms of mega electron volts or MeV.
So now proceed po tayo sa panibagong problem where helium-4 nucleus or 4 He in terms of mega electron volts. We're looking for our mega electron volts. So dalawa po yung ipapakita kong solution. Yung una po is yung long method napapakita po yung complete procedure. And the other one po is yung short method, yung shortcut po natin to direct po na makuha yung ating MAV. Now let's proceed po. So first po natin gagawin is to calculate for the mass defect. Mass defect is equal to alam naman po natin yung formula ng mass defect, versus number of protons times the mass of proton, which is value of 1.00782 5 plus the number of neutron 2 times the mass of neutron 1.008665. So calculate po natin it's equal to 4.03298. Hindi pa po ito yung mass defect natin. In this case of helium-4, the mass defect indicates a loss in mass. So we need to subtract. We need to find the difference between mass of the nucleus and the sum of the masses of its individual proton and neutron. So ito na po yung sum of individual proton and neutron natin. Then we need to find the difference between mass. So subtract po natin siya to 4.00260 or yung ating actual mass, and equals to 0.3038 AMU or atomic mass unit. This will be our mass defect. So meron na po tayong mass defect. Let's proceed to our next. So now let's proceed to the mass energy equivalence equation by Albert Einstein, or our E mc squared, or E is equal to mc squared, where E is for energy, m is for mass, and c is for the speed of light. Next, convert mass defect to energy. But first, express the mass defect in grams per mole. This is easily done considering the numerical equivalence of atomic mass AMU and molar mass grams per mole that results from the definitions of the AMU and mole units. The mass defect of helium-4 is therefore 0.3038 atomic mass unit. Let's convert it into grams per mole. It will be 0.3038 grams per mole. So para naman ma-fill upan natin yung ating mass energy equivalence equation, we need to turn these grams into kilograms. So the conversion is 1 joule is equal to 1 kg. So we need to convert this into kilogram. Is equal to 3.03 times 10 raised to negative 5 kg. Yan. Next, let's substitute na this value to our mass energy equivalence equation. Okay. So yung ating mass is 3.03 times 10 raised to negative 5 times sa ating speed of light, which is 3 times 10 raised to 8. And it equal to 2.73 times 10 raised to 12 joules. Okay, next, proceed. The binding energy for a single nucleus is computed for the molar binding energy using Avogadro numbers. So, let's proceed using Avogadro numbers. E energy is equal to 2.73 times 10 raised to 12 times is our Avogadro number. Mahanap natin to sa mga sites na yung ating conversions and values. 6.22 times 10 raised to 23 and will be equal to 4.53 times 10 raised to 12 joules. So now, our next step is convert this into electron volts. So how? Using conversion. Now, mahanap po natin siya sa mga Googles and so recall that 1 electron volts is equal to 1.602 times 10 raised to negative 19 joules. So to compute is equal to 4.53 times 10 raised to negative 12 times 1 EV electron volts 1602 times 10 raised to negative 19 will equal to 28277,153.56 evolution or 2.82 times 10 raised to 7. So now, electron volts. So now, let's convert electron volts to mega electron volts. So convert electron volts to mega electron volts. You divide energy in electron volts by 1 times 10 raised to 6 or simply as 1 million because 1 so convert, divide natin yan and will be equal to 28.27715356 mega electron volts. Now nahanap na natin yung ating mega electron volts. Pwede na po tayo mag-proceed sa pagkuha ng nucleus or yung ating nuclear, the binding energy per nucleon for helium or now, papakita ko naman po yung shortcut method or yung fastest way para makuha natin yung ating MeV. Diba nakuha po natin yung ating mass defect na 0.3038 AMU. We can easily multiply it by 931. This 931 is because 1 AMU is equal to 131 MeV. So multiply po natin. Same lang po yung lalabas. Let's try. 0.3038 times 931. Nagkakatalo lang po sa decimal points. Yan lang po. Thank you for listening.
Example number 4. During the nuclear fission of uranium-235, the process released a significant amount of energy along with two smaller nuclei, xenon-140 or Xe-140 and strontium-94 or S-94. Now calculate and determine the nuclear binding energy per nucleon released by the nuclear fission reaction.
So, ayan. Let's move on naman sa next problem. So, dito sa problem nito is yung uranium-235 is nag-undergoes ng nuclear fission and nag-produce ng two smaller nuclei and significant amount of energy. Yung two smaller nuclei na yun is ang xenon-140 and the strontium-94. Sabi dito is calculate and determine the nuclear binding energy per nucleon na release nun. So, ayan. Ang uranium-235 daw, nag-undergoes ng nuclear fission and nag-produce ng two smaller nuclei which is the xenon-140 and strontium-94. So, ang task natin dito is mahanap yung nuclear binding energy niya per nucleon. So, ang formula doon is ang E is equal to mc squared, which ang M natin or mass defect is, ang formula natin gagamitin is ang M reactant or mass of the reactant minus the mass of the product. So, bakit ito yung ginamit natin? Bakit hindi yung isa? Bakit hindi yung normal na ginagamit? So, ginamit natin to kasi yung problem natin is nag-undergoes na nuclear fission and meron tayo dito M reactant and M product. Karaniwan, pag ganito yung problem is ganito talaga yung ginagamit na formula for mass defect. And yung value na c-squared natin dito is yung value ng speed of light, which is 3 times 10 raised to 8 meters squared per second squared. So, ayan. Meron na tayong mga value dun sa nuclear binding energy natin. So, para makuha, hanapin natin yung sa value ng mass defect. So, formula nga dun is the mass of the reactant and mass of the product. Yung reactant natin dito sa problem na to is yung uranium-235. And yung mass ng uranium-235 is 235.043 AMU minus the mass of the product, which is yung pinagsamang xenon and the strontium, 139.92 plus 93.92. So, pag nakalculate natin to, is ang lalabas is 1.206 AMU. So, meron na tayong mass defect. Kaso nga lang, sa pagkuha ng nuclear binding energy, ang unit na gagamitin natin doon is joules. So, bago natin i-multiply yung c-squared or speed of light is kailangan muna natin i-convert yung AMU into kilogram. para magawa yun is imumultiply lang natin yung ito dun sa value ng kilogram na 1 AMU. 1 AMU is equivalent to 1.661 times 10 raised to negative 27 kilogram. Imumultiply lang natin to sa nakuha nating mass defect. So, ang lalabas dyan, kapag kinalculate natin to, is, kapag kinalculate natin to, sorry na putol, kasi ang lalabas ay 2.2 times 10 raised to negative 27 kilogram. So, meron na tayong mass defect and naka-convert na din siya sa kilogram. I-input na natin yung mga value nating nakuha dun para makuha yung nuclear binding energy natin. So, 2 times 10 raised to negative 27 multiply the c squared or the 3 times 10 raised to 8 meters squared per second squared. Ang makukuha natin doon is 6 times 10 raised to negative 19 joules. Naka-joules na siya kasi kilogram times meter squared per second squared is equivalent to joule. So, ayan. Meron na tayong nuclear binding energy. Kaso, ang hinahanap sa problem natin is per nucleon. Para makuha yung per nucleon na yun, is imumultiply natin siya sa Avogadro. Ang value ng Avogadro is 6.022 times 10 raised to 23 mole. So, ayan. Kagaya ng sabi ko kanina, imumultiply lang natin yung nakuha natin sa Avogadro's number. So, 6 times 10 raised to negative 19 joules multiply by the Avogadro. 6.022 times 10 raised to 27 mole. Kaso, may problema tayo dito. Nakamole yung unit ng Avogadro and kailangan joules din yung lalabas dun sa kukunin natin. So, para magawa yan, is i-divide lang natin to sa 1 mole para ma-cancel to. So, i-compute na natin to. 6 times 10. Ito natin computation. Raised to negative 19. Multiply by 1 over 6. Taba? 6.022 times 10 is to 20. 27. I'm sorry. 23 pala yung value ng Avogadro. Nagkamali ako na lagay. 23 to. Sorry. Raised to 23. Ano makuha natin dyan is 9.96 times 10 raised to negative 43 joules. So, ayan. Dito sa problem na to, ang nuclear binding energy per nucleon ay 9.96 times 10 raised to negative 43 joules. Ayun lang po. Salamat.
Good morning, everyone. Now, in this example, we're going to find the total energy released of 8 uranium-235 which undergoes a nuclear fission. Now, before we start, we will first balance the equation by finding the missing element. So, paano po natin makakompute ang missing element? Let's start with its atomic weight. So, kung makikita natin sa mga given, kumpleto ang atomic weight na given. And this part, which is the reactant, should be balanced with the product. So, ibig sabihin, kapag pinag-add tong dalawang to, equal sa pag pinag-add tong tatlong to. So, gagawin natin yan by putting them all in one equation. 235 plus 1. Yung dalawa, yung yield, gawin natin siyang equal para mas madali. 84. And the missing atomic weight, which is, i-represent natin siya as N, plus 14 na 1. Ngayon, isosolve natin siya directly. So, 235 plus 1 is 236. Then 84 plus 14 is 98. Plus N. So, masasolve na natin siya ngayon by paglilipat-lipat na ito. So, N is equivalent to 236 minus 98. Now N is equal to 236 minus 98 is 138. Now we all know na ang atomic weight na nawawalang element is 138. Let's proceed to finding what element is missing. Same process lang, but this time yung mga nasa baba, which is also known as the protons. So, pag-equate natin yung protons, 92. Protons are periodic number. Plus 0 is equal to 36 plus the missing term and plus 0. Yan na po ang ating magiging equation. Now, 92 plus 0 is common na, 92. Then 36 plus 0 is also 36 plus n. Now, same process lang dito. Mangyayari is n is equal to 92 minus 36. Now, n should be 92 minus 36 is 56. Now, alam na natin na pang 56 siya sa periodic table of elements. Now, kung hahanapin natin siya dito, malalaman natin na siya ay ang baryum. Ngayon, na-balance na natin na equation, mag-proceed na tayo sa ating next step. And let's now proceed in computing the total energy released. So, paano nga ba yun? At first, we should take note that this is the atomic weight. Ito yung number of protons, or also known as the periodic number do sa element, kung bang ilan siya. And kapag pinag-subtract natin ito, makukuha natin is the number of neutrons. So, paano natin gagawin ito? So, at first, we should write the number or the number of protons ng element na yun. Now, dito sa isotope na to, makikita natin na 92 yung kanyang number of protons. So, 92 times 1.007825. Now, kinonvert natin sila lahat sa AMU para mas madali natin isolve yung total energy release. Hindi kasi natin pwedeng gamitin yung mismong number dahil kailangan mo natin siyang i-convert into AMU, which is nandito yung mga value ng katumbas ng isang neutron into AMU and isang proton into AMU at 931 MeV is 1 AMU. So, compute natin doon para hindi tayo mamali sa ating solution. Now, tulad ng sinabi ko, 235 minus 92 is 143. So, yun yung gagamitin natin dito. So, bakit nga ba 143? Pag pinag-minus natin yung atomic weight sa number of protons, makukuha natin yung number of neutrons ng element or ng isotope na yun. So, times, conversion ng is 1.008665. So, pag nakuha na natin yan, plug in natin sa ating calculator. Times 1.007825 plus 143 times 1.008665. Makukuha natin 236.958995. Diba? Babalik natin sa ating calculator. Tama. Ngayon, hindi pwede yun. Isasubtract pa natin to sa kanyang isotope or sa kanyang isasubtract natin to sa kanyang atomic weight or in this given, do sa atomic weight ng isotope na yun. So, in this case, 235 ang kanyang atomic weight. So, isasubtract natin to. So, 238. Now, 236.958995 minus 235. Sagot, 1.958995. Now, hindi pa ito yung pinakasagot. Meron pa tayong gagawin. I-convert pa natin to into MeV. So, paano? Just multiply the answer to 931 para maging MeV siya. Kasi ang 1 AMU is 931 MeV. Now, in this case, ang 1.958995 ay ilan sa MeV. Now, i-compute natin. 931 times 1.958995 equals 1.958995 times 931 is 1,823.824345. Now, yun na yung sagot niya in terms of MeV. Now, let us proceed in computing the krypton and barium. Sa krypton, same procedure lang, 36, yung atomic number or yung kanyang proton, times the conversion, 1.007825 plus 84 minus 36 is 48. Yun yung kanyang number of protons dun sa krypton element. Times the conversion, 1.00866 and 5. Now, solve natin siya. plus 48. Now, ang sagot ay 84.69762. Ngayon, nakuha natin yung value na yan, hindi pa yun yung pinakasagot, dahil isasubtract na natin siya sa kanyang actual atomic weight. Now, directly sub na natin dito sa anong pag na pahaba. Lalabas ay 0.6972, ay 760. Ngayon, yung sagot na yan, i-multiply din natin siya sa 931 para ma-convert siya into MeV. Now, 0.69762 times 930 times 930. Ang sagot, 649.48422 MeV. Finally, let us compute for the baryu. Sa baryu, gagamitin natin ay 56 times 1.007825 plus 138 minus 56, 82. So, saan galing yung 82? Minus natin itong 138 sa 56 para mahanap yung number of neutron. And, proceed tayo. 1.008665. So, ngayon, nahanap na natin yan. I-complete na natin. 56 times 1.007825 plus 82 times 1.008665. Isagot, 139.1487 and 3. Ngayon, yung nakuha natin value na to, isasubtract natin sa kanyang actual atomic weight, which is 130. Minus 138. Which is equivalent to 1.14873. Ngayon, may isang step pa tayo, which is i-multiply natin sa 931 para maging MeV times 931. Ngayon, pag pinag-multiply natin yan, ang sagot ay 1,069.46760. Ngayon, buburay natin to and i-list out natin yung nakuha nating tatlong value. Ngayon, na nakuha na natin yung tatlong value, which is itong una ay galing sa reactant side, yung sa uranium, then itong dalawa ay galing from krypton and barium. Ngayon, simpleng step na lang ang gagawin natin. Itong sa reactant side, ima-minus natin sa total ng product side. So, paano yun? 1823.824345 minus 649.48422 minus 1069.46763. Ang kanyang total answer is 104.872495. Ito yung kanyang total energy release in MeV during the nuclear fission. Yun lang po. Thank you.